Hello, we have calculus homework number 19 from handout number 8 involving writing cost, revenue, profit, and the like. So, starting with number 1, we have a leaf blower company that makes noise suppressors. Its fixed costs are $30,000 and its variable costs are $10 per unit, and it can sell a suppressor for $25. So our cost function for this will be our fixed cost plus our variable cost. So that's fixed cost plus variable cost. And for our fixed cost, that's given to be $30,000. And our variable costs are $10 per unit. So that will be 10 times the number of noise suppressors we make. So this right here is our cost function. Go ahead and zoom in a little. For our revenue function, this is just based off the price of the item. So we're selling it for $25 a piece. So that means our revenue will be 25 times the number of these things we sell. So finally, our profit is going to be revenue minus cost. So for us, that will be 25Q minus, and I'm going to use parentheses here to make sure my signs work out, minus 30,000 plus 10Q. So our profit function in the end is 25 minus 10Q, which is 15Q. It's not a Q. Minus, so 15Q minus 30,000. So we have cost function from our fixed and variable. We have our revenue function from our fixed price. And we have a profit function, which is revenue minus cost. For marginal cost, I can do this very easily. So because my cost function is linear, then my slope for this cost function, which is 10, is my marginal cost. So my marginal cost is 10 because C of Q is linear, which means that marginal cost is equal to the slope of that linear cost function. The same thing is true for marginal revenue, right? Because my revenue function is linear, the slope of my revenue function is my marginal revenue. So for selling one more, it would just be $25. Marginal profit, believe it or not, same deal. The slope of my profit function gives me my marginal profit. I would make $15 more in profit for selling one more item, right? And again, this is because of these being linear functions. So because, in this case, my revenue function is linear, my marginal revenue is the slope, and then same thing for profit. Because profit as a function of Q is linear, then my marginal profit is the slope. So, how many must we sell to break even? Well, the break even point occurs when cost equals revenue. So, I'm going to set these two functions equal. So my cost function is 30,000 plus 10Q. My revenue function is 25Q. So, rearranging this, I have 30,000 equals 15Q. Divide both sides by 15 to solve for Q. And so, with a little bit of calculator work, or if you don't want to do any calculator work, you don't need to, you should need to sell 2,000 units in order to break even. Again, that is from when we set cost and revenue. Question 5. If a company prices their 5-finger at $85, it sells an average of 55,000 pairs of shoes in a year. At $95, it sells an average of 45,000 pairs of shoes in a year. It costs $40 to make a pair of shoes, and their overheads are $500,000. So let's assume demand is a linear function. We want to express quantity sold as a function of price. So let's visualize this real quick with a graph. So we have a situation where we have at $85, it sells an average pair of 55,000 shoes. So for a PQ plot, so price and quantity plot, we have a situation where we have $85 sells 55,000 shoes. So I'll write 55K. So this is $85. Then at $95, it sells 45,000 shoes. So $95, it sells 45,000. So we can see that this is a demand curve because it is going down and to the right. So we're assuming it's linear between these 2 points. And we're going to look at making a function that is linear here. So first we need the slope. So the slope here is going to be 55,000 minus 45,000 over, I'm sorry, this should be the opposite way. My bad. This should be 85 minus 95 over 55,000 minus 45,000. And so if I plug in this slope, I have negative 10 over 10,000, which is a very small number. It is a thousandth, so it's 0.001 and negative. And that's my slope. So my PQ function would be something like P equals negative 0.001. And then we have times Q plus P0. So I'm going to go ahead and just plug in one of these points to find P0. So I'll go ahead and just plug in the 85 and the 55,000. So my price is 85 equals negative 0.001 times 55,000 plus P0. I'm going to solve this for P0. So I'm going to multiply out the 0.1 and the 55,000, which is 55. So then I'm going to add 55 to the other side. And I'm going to get P0 as 140. So right now my equation is P equals negative 0.001Q plus 140. Now, the tricky part is that we want to have the quantity as a function of price. So I actually need to invert this equation. So in order to do that, I'm basically just going to be solving for Q. So I'm going to have P minus 140 equals negative 0.001Q. And then I'm going to divide both sides by negative 0.001. So I'm going to move Q to the other side. If I have 1 over 0.001, this is actually going to be This is going to be 1,000 times P. And then we're going to have minus 140,000. So when price is 0, I'm sorry, this should be plus 140,000. So when price is 0, actually I believe this should be negative, I'm sorry. So when price is 0, we have 140,000 things sold. So that would be the Q-intercept here. So this here is our Q as a function of price. So for 6, we're expressing cost, revenue, and profit functions. Now our input is price, so we have to be careful here. So cost as a function of quantity is going to be fixed cost plus variable cost. So we have to go up here and we have to say, all right, our fixed cost is 50,000 or 500,000, and it costs $40 to make a pair of shoes. So our cost as a function of quantity is going to be 500,000 plus 40 times the number of shoes. Now, we want our input to be P, so we want it as a function of price. So we're going to take our Q, we're going to plug it in. So our cost is going to be, if we want to do it in terms of P, we're actually going to do cost as a function of Q of P. So we're going to substitute this in. So we have 500,000. 500,000 plus 40 times negative 1,000 P plus 140,000. So our cost as a function of price is going to simplify a little bit here. So we have 500,000 minus 40,000 P plus, I need a calculator for this, 5.6 million. So one more step of simplification here, and we have our cost as a function of price is going to be 6,100,000 minus 40,000 P. So that's our cost function. Now we need to go into our revenue function. So our revenue function is going to be quantity times price. So our quantity function that we got from up above was negative 1,000 times P plus 140,000 times P. So to simplify this, we have our revenue function, which becomes negative 1,000 times P squared plus 140,000 times P. So there's our cost and our revenue functions. Now let's go ahead and make our profit function. So our profit function in terms of price is going to be revenue in terms of price minus cost in terms of price. So when we substitute these in, so we have our revenue function, which is negative 1,000 P squared plus 140,000 P minus, I'm running out of room here, so I'll go over here. So we have minus 6,100,000 minus 40,000 P. So our profit function then, if we simplify this, becomes negative 1,000 P squared, and I have 140,000 plus 40,000 P, so that's 180,000 P, minus 6,100,000. And this is our profit function. So we have cost, revenue, and profit put all together. Going on, number 7. So we want to find the price of the pair of shoes that maximizes this profit. And the hint here is that it involves the vertex of a parabola. It's a terrible underline. The vertex of a parabola. And then we want to know how many people will buy these shoes at that price and what is the maximum profit. So I'm going to pull down my profit function, which is negative 1,000 P squared plus 180,000 times P minus 6,100,000. So this is my profit function. If I go into my calculator and I plot profit as a function of P, I'm going to end up with a parabola that looks something like this. And what I want to do here to maximize this profit is just find the maximum value of this parabola. So go in to your calculator, plot this function, and I will give you a moment to do that. So when you do that, you end up with a x coordinate, or a price rather, of 90, and you can plug this number right back into your profit function. So that's negative 1,000 times 90 squared plus 180,000 times 90 minus 6,100,000, and you get a profit of 2 million here. So we have to do a little interpreting here. So what is the maximum profit after this price? So we have price is $90 per pair for a max profit of $2 million. So this is part of our answer. The other part is we need to figure out how many shoes we will actually be selling at this price. So we go back to our quantity function that we found to be negative 1,000p plus 140,000. So we have Q equals negative 1,000p plus 140,000. And we end up plugging in our 90, so negative 1,000 times 90 plus 140,000 will give us the quantity of shoes we sell. And so that quantity is just 90,000 subtracted from 140,000. So the quantity we sell will end up being 50,000 of these shoes. So this is sold at the $90 price point. Terms of price. Finally, number 8. A bus company offers sightseeing tours in DC. One tour priced at $11 per person have an average demand of about 1,000 customers per week. So a market survey indicates that for each dollar decrease, the number of passengers increases by 200. In addition, it costs the company an average of $2 per person to run these tours. So find the tour price that should be charged to maximize weekly profit, and then what is that maximum profit? So number 8 is asking us to do what we just did in the past couple problems, but in one go. So let's do all of the steps. First, we're going to find a cost function. So cost as a function of quantity is just going to be $2 per person. So we'll say $2 per person. Our revenue is going to be $11 per person. Actually, I'm sorry. Our revenue is not $11 per person. It's going to be our quantity times our price. So we need to figure out our price. So our price comes from what we did earlier, where we have a PQ graph and we have 2 points. So if we have $11 per person, then we're going to have 1,000 customers. If we reduce the price by $1, the number of passengers increases by 200. So if I reduce the price by $1 down to 10, then I will have 1,200 passengers. So I have, again, a demand curve like this that we're assuming is linear. So the slope of this is just going to be 10 minus 11 over 1,200 minus 1,000. So this is going to be negative 1 over 200, or 0.005. And then we need to put together our function. So we have P equals negative 0.005 Q plus P0. Then we need to plug in a point to find P0. So our price, we'll just do 11 equals negative 0.005 times our quantity of 1,000 plus P0. And then I'm going to solve for P0. So if I solve for P0, 1,000 times our negative 0.005 would give us just negative 5. So we'll add 5 to both sides. So our P0 is 16. So our final price function as a function of quantity is negative 0.005 Q plus 16. So now we're going to need to turn this again into a quantity as a function of price. So I'm going to invert this. So I'm going to solve for Q. So I'll do P minus 16 equals negative 0.005 times Q. And then I'm going to rearrange this, put Q on the other side, and divide everything by negative 0.005. And what we end up with is negative 200p plus 3,200. So this is our quantity as a function of price. So I can take this and plug it into my cost and revenue functions. And so my cost function in terms of price is just going to be 2 times negative 200p plus 3,200 equals, so we'll simplify here, so negative 400p plus 6,400 is our cost in terms of price. Our revenue in terms of price is going to be our quantity function, which is negative 200p plus 3,200 times just p, which is our price. And so this will be negative 200p squared plus 3,200p. And going to the next step, we want to find our profit function. So profit in terms of price is going to be revenue minus cost. So negative 200p squared plus 3,200p minus, and I'm using parentheses here, negative 400p plus 6,400. So simplifying this, my profit function then becomes negative 200p squared. So I have 3,200p plus 400p. So this will be plus 3,600p minus 6,400. So be careful of your signs. So this is my profit function. So again, I'm going to go to my calculator. I'm going to have profit in terms of price. And I'm going to have a parabola that looks something like this. And I want to find this maximum point. So when I go in and find this maximum, I'll plot this point, or plot this equation rather. So we have negative 200, and we'll just do x, negative 200 times x squared plus 3,600x minus 6,400. This gives me a coordinate where the price is 9, and the vertical value of that would be negative 200 times 9 squared plus 3,600 times 9 minus 6,400. That gives me a profit of 9,800. So let's remind ourselves what we're trying to do. We want to find the TOR price to maximize profit and then find that maximum profit. So the maximized price, so the maximized profit for a certain price would be maximum profit of $9,800 per week for a price of $9 per person. So this is per person, and this is per week. So just as a recap, let's go through and say what we did. So here I have cost and revenue in terms of quantity, but I don't want it in terms of quantity. So what I do is I go into my information for price and quantity and calculate the slope of a linear section. So this is the second thing I did. And I use that slope to find an equation for price, and then I need to find the intercept for that equation. So I found the intercept for that equation, and then I came up with this equation for price. But I need Q as a function of P. So I actually invert this and get Q as a function of P. So from there, I take it and plug it back into the cost and revenue functions I had initially. So I have cost as a function of price and revenue as a function of price. And then I put these together and get a simple or a single profit function that combines revenue and cost in terms of price. The last step is, by whatever means you choose, I take my profit function and I find the maximum value of that profit and the price that gives me that maximum profit. Then a really important step that is sometimes overlooked is make sure you interpret that information. Don't just leave it as this graph and this point. Make sure you say the maximum profit is $9,800 and the price is $9. Questions 9 through 11. These questions refer to information from a table. So part of this is just reading tables. What is the profit of the company at a level of production of Q equals 4, 6, and 8? So profit, recall, is just revenue minus cost. So if Q equals 4, then I would want the revenue when Q equals 4, so that's 36, minus the cost, which is 32. So this profit is $4. change colors. The profit at Q equals 6 is going to be the revenue, which is 54, minus the cost, which is 49. So this profit is $5. And then finally, we have at Q equals 8, the profit would be our revenue of 72 minus our cost of 70, or just $2. Our marginal profit for making one additional item would simply be, what is the profit of making one more of these? So, how do we go about doing this? Well, using the same colors, my marginal profit, I would look at the profit of 5 minus, so here I'll say marginal profit is the profit of making 5 minus the profit of making 4. Because remember, marginal is how much to make one more than this. So 1 more than 4 would be 5. So my profit at 5 is going to be 45 minus 40. So this profit is going to be $5. So I'll call this my profit column. And therefore, my profit would end up being $5 minus $4. So my marginal profit is only $1. Going on to the next one, I'm going to be looking at the marginal profit for 6, which would be the profit at 7 minus the profit at 6. So I'm going to look at 7. So this next profit would be $4. And I'm going to say, all right, my marginal profit then would be $4 minus $5. So this marginal profit is actually a negative $1. I'm actually going to be losing money by making one more at that point. Then finally, my marginal profit for Q equals 8 is going to be the profit at 8 minus the profit, the profit at 9 minus the profit at 8. So we end up with, going back to our table, we end up with a profit here of negative $1. So our marginal profit would be negative 1 minus 2. So we end up with, in fact, a marginal profit of negative $3. So we really are losing $3 per item by making one more. Finally, what production level would maximize the profit and what is the maximum profit? So if I'm looking through this entire table and I look at profit, I do revenue minus cost. So here my profit is negative 10, here my profit is negative 5, here my profit is negative 1, positive 2, positive 4, positive 5, positive 2. So it appears that my maximum profit occurs sometime between making 5 and 6 of these items. So we can say Q equals 5 or Q equals 6, and the maximum profit is simply $5. So since we really can't deal with fractions of an item, we really can't say that it's between 5 and 6. We would say either 5 or 6.